let's go into sales predicts. I will do some copy and paste because I'm a bit lazy to type. Because I already prepared the source code already. I will be going through the steps on explain how do you run all the stuff. So let me do some copy and paste. So this is how we input. Okay, we import libraries. I won't be using C4 today, but no. Sklearn, yes, standard Sklearn. Okay, I will be using this one. So NumPy pandas, if you came across with data science stuff, I bet you'll be able you know on this. For other beginners, NumPy is the mathematics library. Yes, mathematics mean cumulative values, and then there's a lot, log, exponential, all the algorithms that we learned in secondary and tertiary studies, everything is in the NumPy. Metrics as well. And then pandas is the one that built on top of NumPy, where the best thing for NumPy is you are able to import table form data. For example, Excel file, CSV file, you can import into Python by using pandas. Datetime library from Python. Sklearn, this is a standard scaler, and one of the best tool, especially for people that as lazy as I am, I use Panda Portfolios. You can search on Panda Portfolios. This one. So later, I will show you on generating the Pandas portfolio. Let me share this link to you guys. This is something very useful. It saved up a lot of my work. So, so this is how I import all the CSV. So you can see that I have my data inside here. All of them is my CSV data. Yep, you can see all of them CSV data. So Microsoft Excel spread. So this is all my CSV. And by the way, this is Jupyter Notebook. I'm running inside my local. This is my browser. So if you install Anaconda, you'll be able to run this Jupyter Notebook itself. So this is how I import the data. So I use pandas and read CSV. I need to provide the path to the CSV file. And I have 4 different files over here. So I have the item categories, the item sales trade, the training data, and then the shops. So let us see what are the data that we have. And let's go for. So dot head will give us the top 5 rows of the data set. So this is what we have, the name of the data and then the category. And the next one is DS items. These are the items. Same thing, I have items. This is category, item ID and the category ID. And then we have shops. So this is a shop name and the shop ID. And the last one is the sales trend. This is the data. So from here. Over here, I have date. I have date block. Date block is the week block. And then, oh no, this is the month block. And then this is the shop ID. And shop ID is this ID. So most of cases where we build the database at time, we have different tables, and then we use primary key and foreign key to map the data. So most of the time we use the ID to map the data, and then I have item ID, and then I have the price for the item and the count. How many items did I sell for each day over here? So this is how we show the data from the CSV itself. Now, next thing is I want to merge the data set. When I do machine learning trainings at time, shop name doesn't really affect my sales, right? As long the product that I sell in my shop is good and it's cheap, everyone will come and find me already. Yes, that's how human behave. So I will neglect shop over here. And what I interest from here is I have item category, and then I have items over here. I'm I'm more interested with the item category over here because it somehow uh, help me to generalize all the items. Because instead of like, let's say if I want to buy, uh, give me an example. I want to buy a shirt, right? There's a lot of brand, name it. Uh, what kind of brand do we have for shirt? Giordano, LV, and so on and so forth. I'm not good on this one. Uh, and we normally we just group them into a general. So we have a item category over here. So what I want to do is I want to merge my sales trade data, and then I want to have the item category. We can use uh, equal to PD merge sales. Then I want to merge with this one. So copy, and on the because I have the item ID over here, and then I have the item ID inside my this DF. So I just use the item ID, and I use how I've joined. If I do this one, so now you can see I have the item name over here, and then I have the item category, and I match this one with the item ID over here. So this is how we merge two different CSV. You see, it's that simple in pandas using Python. If I ask you to do the mapping by using CSV, I bet it will take some time for you to do that. I just need to have one line of code, then I'm able to merge them already. Okay, now this is the first 5 rows of my table, and this item name doesn't give me anything, so I want to take it out. Pop item name. So pop will help me to take out the item, the column. So if I print out again, you can see that item is gone from my tables already. Okay, so I have the date, the block over here. Now the next thing, first things I will say I'm a bit lazy, right? For the data explore data analysis, right? Normally I will use profile report, pandas profiling. If I run this one, it will take some time to do the processing, and after that it will give you a very nice data analysis report directly. So you don't really like need to go through one by one to do your analysis and understanding the data itself. Let's wait for a while. It will take some time to do the data processing. And of course, I'm running inside my local machines. Okay, if you have any questions, you can ask me. Yeah. So just now I went through using pandas to read data from CSV, and then I use pandas to merge two different CSV data into one. Uh, you might ask me, Edmund, I can use CSV or Excel spreadsheet to build my analytics. I can draw charts inside. Yes, you can definitely do that. But I will tell you one thing is if the CSV or Excel spreadsheet is more than 10 MB, how long do you need to wait for it to open? And then once you want to do any charts calculations, and how long do you need to wait? But using pandas, I'm able to read one single file, CSV or Excel file with 200 megabyte within few seconds. I'm able to read the data directly from there. So it really depends on the data set. And then if you are processing a very huge data set, then I will always recommend to go into Python and pandas to do your data analysis. pop is to take out the uh, is to take out the column. Drop is to direct delete off. So normally I use pop because if I want to put it back, then I can just insert back. Uh, how to invest? Okay, we have a question. How to investigate any area if there is any when to do the join? Uh, when to do the join? Because I want to join. I want to get the item category inside my training data set. That's when I use the join. And when do you? How do you know? Investigate the data area is when then there's error happening. Normally it will prompt up. So why is it so slow? Hey, come on. Normally it will give out some of the some of the what the error loggings. So you need to investigate your error from there. Mm, Wing. Okay, we have a question from him. What laptop spec you recommend through data scientist window Apple? You can perform your analytics. Anything in Windows and Apple, both of them is good. Um, if you have the budget, then I will recommend you go for MacBook because MacBook is very expensive. Uh, Everyone knows that. It's more like, but one thing is, the MacBook I got here is 2015. MacBook is 2015, and until 2020, I'm still using. So you can see how sustainable for my MacBook itself. So it depends. Assuming we are able to master the basics of applying various Python libraries for ML, what are example projects that we can attempt on? I will show you some of the. Okay, this is taking too long. Let me stop this one first. Okay, so this is the error message that we will get. Uh, okay, let's wait for another while. Uh, I will show you one website later. What are the things that you can do. So later you can proceed from there. And then another question is the underscore a function where if you inflict back to the data frame that undergoes the pop? No, because I don't really need to use the item name, that's why I just save inside underscore. So it's like, for me, it's like a rubbish bin and throw everything inside underscore only. So it's like it's a variable for me. Okay. Do you have any experience on SAS that have similar report import export for data analysis? Of course, it's not really used for ML. Pandas, you are able to import SAS file. You can export the data in SAS, then you can use Pandas to read. So no problem. Is cohead better than merge? It depends on the purpose. The reason why I use merge is because faster over here. Can explain what is merge used for line 7. This one? Oh, if you see that the df sales string, this is the table I have. And then this is the data frame for items. I'm merging this one with this one, but I'm using left join is because this is the base, and then I want to use this one as my base, and the data will merge from this one to this one based on the item ID, and then this is my result. Will this source code be in the slides? No, the source code will be inside the slides, but the source code will be provided to you if you stay until the end. Oh, come on. While waiting for it, we just go through some of the codes first. Once it's ready, then you'll be able to see. Okay, this is one of the functions that I created. More likely is to remove duplicated data from my site. Uh, this is a functions on how normally I will create a lot of functions in my programmings or my libraries, my own libraries. I wrote a lot of my own libraries handling different kinds of like uh, external libraries like Firebase, Google Cloud Platform, BigQuery, and all sorts of libraries. I wrote my own libraries to use them. So most of the time I do a lot of copy paste. So then I don't really need to write again to perform the same task itself. Uh, no worries. All the codes that I written as library, I will be also passing to you guys during the classes. So you save up most of your time going through all the documentations. It's like very very headache for me to go through documentations as well. Yanwa, how to train messy data text format? Uh, best best thing I ever use is regex, regular expressions. If you're not familiar, you can search for regular expressions, or we call them as regex. Okay, now the next thing is copy and paste again. So this one is I want to create my subset. I want to get the data out and I want to drop the duplicated data. So once I run this one, it will print out some of the what is finished. It will print out the length after drop and what's the total duplicated data I have inside my data frame. Okay, so this is one thing. And still remember I mentioned that I want the item category over here. I have a lot of categories over here. Like later after this one finish running, 71% finally. After this one finish run already, I will show you the category data. But of course, since we have a lot of category data, and most of the time is I want to avoid too much of category, or we have too much of uh, category. There's too much category will give us a lot of noises. So what I want to do is I want to reduce them into smaller groups. So I can use this one, copy and paste. So can you see 1 and 8 over here? 10 to 18, 18 to 25. These are the item ID that I went through the CSV. I'm able to get, and then I rename the ID into access console games, phone games, CD games, card, movie, books, gift, and soft toys. And I save them inside a new column of my data frame. Okay, still 25%. Few more to run. So this is to give a name for the category, and from item ID from 1 to 8, all of them will be having access name, and then 10 to 18 will have console, 18 to 25 console games. So from here, I further summarize the items into a smaller categories, and then I save it inside my data frame, which is this table. Uh, this table. Hmm. Next one. After that, this is the one. So this is what I'm doing is I want to, because this table, still remember this table? I convert the table, right? So this date, can you see the date over here? This is a string date. So what do I mean by string is it's a text. In order for us to extract month, year, day out from this text file, we need to convert it into a date time uh, datetime format. So this code is to datetime is to convert that column into a datetime data set, and then I replace the data with the date itself. So this is to convert, and then I also need to provide the string format of my data. Oh, coming already. So this is the pandas profiling. Okay, over here, I'll go through a little bit. So this panda profiling, right, it will tell you that I have 7 variables, and then I have these numbers of data points. Duplicated rows, I have 6, and then total size in memory. So the file size is around 94 MB, and when I place inside pandas, it occupies 344 MB in my memory. So be very careful if you use pandas. If I remember correctly, it's like 200 MB will occupy 2 to 3 gig of memory, your RAM memory inside your computer. So this is the variable. Date doesn't show me anything. So date blocks number, I have distinct count 34, and then I have the mean of 14. Block doesn't tell us anything. The thing that is in common value. So over here I have like 11. The 11 it has 143, 100, and 246 counts, and then it occupies 4.9%. And this is extreme value, maximum, and 33, my maximum value is over here. So I will print out the value later to show you what does this number stands for. Okay, and then I have shop ID, item price. So it will give me a mean of 890. And if I toggle the details, and then I can play around histogram, dynamic, tell me not much. This is my histogram, common value. So over here, there will give you a lot of like charts over here. Yes, this package, this exists. I sent you the link inside the group chat already. Interaction. So for example, I want to set my y-axis and date block numbers, and then if I click on shop ID, this will my y-axis will change to shop ID, and this is my x-axis. So I can change this one according to see the patterns of my data set. And the best thing is there's correlations that help you to calculate the correlations of the items. You can see the correlation between the features, positive and negative correlations, which is one of the way to narrow down the features on which one to select if you want to build your own models, right? I rely on a lot of correlations when I want to build my models at that time. But most of the time, you won't be able to see these colors. Yes, you won't be able to see this color. You need to do feature engineering to come up with your own features. Then you will be able to see some correlations. If you are able to see positive and negative correlations in this is like around 75%, and this is around 75% as well. So if you have this much of dark colors, then congrats, you're lucky. Most of the time, plain. Not much of signals over here. And then this is the missing value, not much of missings. Samples, data, first 10 lines and last 10 lines data. So can you see? Date block numbers 33. So 33 is pointing to October 2015. So all 33 is pointing to October 2015 data. And 0 is pointing to 2013 January data. So this is the date block number. Okay, this one dot duplicated. When I run this one, it will tell me that because from the pandas profiling, it tells me we have duplicate data already. So we have this one to remove the duplicate data from here. Before I drop, I have 293,000, 2,935,849, and then total duplication is 24 data set. Okay, no worries. All the library that I tell you guys is inside Google Colab, so you can use that. So no worries on all. And then when I rename This I rename, and then when I print this one out, still remember the item category. This is the item name, the category, and this is the category's name that I give them. So you can see that 1, 2, 3. If I print 10 out, you can see that I have other names. So I don't really know this was this, was this. Okay. So over here, I convert the date time. Can you see the date is already converted into dash? So this is the default format for the date time or the date for in Python itself. So once you can see this one, so it already converted to date time is as a string data. Now I want to get this cat in into my data frame. Same thing. Now data. So this is a new variable. I want to merge my df and this one on item category and in. Oh, so I have the cats over here, the categories over here already. And the next thing is I want to get the I want to remove this one category name. Okay, I want to remove the category name, and then I also want to remove my month, year and month. Okay, dot pop. Want to pop up my because the reason why I convert the date is because I can do a lot of like analysis on okay. Let's that one first. I can use on this one. Yep. Okay. After that, I want to do. Let me spell out a bit. Yeah. Okay. The next thing is just leave out the date over here. The next thing is because when we want to do any machine learning, right? One of the things is algorithms. All the machine learning algorithms, everything is in mathematics. In order for us to throw the data, our table data, into our machine learning algorithms, we need to convert the categories, the string values into digits. Yes, numbers. So in order for us to do that, right, we can use sklearn, the pre-processing label, and then I want to fit my labels over here. And let me do here. So can you see my categories become 7, 8, 8, 8. 7 is my movie, 8 is my music already. So you might ask me, Edmund, isn't that this will create bias? Yes, it will create bias for my models. Later we will transform the data into the other way format. Then you will understand why I do something like that. So you want to convert it into a. I want to convert this one into a pivot table. So this is the one. And once this one print out, so can you see 0, 1, 2, 3, 4? This is the the block, and this is the category over here. And over here, the numbers over here indicates that how many items did this category sell within that month. So for the one over here, you can see 31. So for item ID equal to 30, And inside the category of 7, which is the movie, I sold 31 items in the, this 0 is January 2013, so 1 is the February 2013. I sold 31 movies in February 2013. So it goes all the way to 33 itself. And then this is how we create. And the next thing is I want to reset this one. Because this is, I want to reset this column. So I use reset index. So this block will become another column over here. And then I want to do a list of range. So I have like 0, 1, 2, 0, 1, 2, 3 until 33 over here. So if I print this one out again, can you see? 0, 1, 2, 3, 4, 5, 6 until 33. And then the date block number, it becomes the ID over here already. So this is the difference when we reset. If we can't really push this data frame into machine learning because this is that's an index over here. And then can you see this 0? There's no 0 over here. We need to reset it. Then we are able to get all the zeros in one row by one row in order for us to throw into any machine learning to do our modeling or any predictions. So be very careful when we want to throw in the data, yeah? So the next thing, this one. Next thing is, still remember this one? The gradient boosting, right? So the next thing is we want to set up the gradient boosting method. So before that, I will need to import my library, and then I also need to import my setup setting. So this is the next step that I want it to go. If you came across on machine learning algorithms classes or data science classes, if you remember that we have the bell curve to see that the learning rate where the line will bounce deeper and deeper to the bottom of the bell curve. That is the max depth, and then the child width, ETA, and then the seed itself. And now I want to prepare the modeling. This is the model. So this one, it will take everything inside my data frame, shop ID, item ID, categories, all the way 0 to 33 as my X feature. And this one will be taking 0 to 33 as my Y feature because I want to train them to do on the predictions. And if I do this one, this will be my model. So this is the one that we train. This is my model. And then this is the gradient boost will train my models. And it will take in the parameters, the setting. Once I got this one, and this is the predictions. So if I run this one, and now I already run my algorithm, my machine learning trainings ready. And I already have my model as my XGB train. And then I have my predictions model out already. And the next thing is I need to measure my accuracy, right? In this case, we can't really measure the accuracy because we don't know what's going to happen in the future. The only way for us to measure is when on the next month, when I know that the prediction of my sales is I have this number, and when the end of next month, if the value matches or is close enough, then I know that what is the accuracy already. So before we do that, right, what we can do is we can do a root mean square error over here. So this is the predictions. Root mean square, the higher the value, the more error we will be able to get. So we want to keep this value as small as possible. And the reason is because why we have 4.25 over here, we are trying to fit every month, or we call it every month and year into our data set itself. One thing you need to know is the user behavior will change according to time. Yes, this is for sure. Your user will change. Even the user purchase behavior will change for the past 2-3 months itself. Uh, that is what we notice from the customer data. And from our cases is we try to fit in 2013 data all the way to 2015, which is it might be the 2013 data is the signal for 2013, but it's a noise for 2015 data. Okay, the year of 2013 data is the signal for the predictions for 2013, but it's the noise for our 2015 data. So my use case is I want to train my models only for that particular month. Okay, so based on this one, I want to change my value over here is with this one. Let's say I want to get the last month over here equal to 33. And of course, when I want to do my X feature that time, I don't want to include my 33 over here. So this one out, and then I run my training. Okay, then we run this one. Can you see? The root mean square is 1.26 already. So it reduces from 4 to 1.26. So you can see that the hypothesis that I made just now is the signal for 2013, it might be the signal for year 2013, but it's the noise for 2015. So this is how we play around with our machine learning, and this is most of the time I will spend inside my machine learning trainings, changing the settings and changing the models itself. For this case, right, normally when we want to predict a certain categories at the time, normally what I will do is this is a quite a straightforward predictions. Normally what I will do is I will put them into smaller cluster to do predictions, because let's say I have two clusters, cluster A and cluster B. The signal for cluster A will be the noise for my cluster B itself. If I merge these two clusters together, I will have a result of no signal for this big group. But if I split them up into smaller grouping, then I will be able to have a more precisions or accurate predictions on my cluster compared to merging them together. So when you build a machine learning, right, you can't target a very big group of people or big group of data. You need to go narrow. Then you need to get something, get the result to have accurate. So you won't have too much of true false or false true, true false and false true predictions or classifications. Okay, so don't build this experience where don't build a very huge model, build smaller one and then target specifically. So it's easier, and then you don't it might be very tedious to train one by one. If you have a lot of cluster, then you need to train a lot. But if you want to have uh, that will be the first phase if you want to target to do testing. Once you have that already, then you can move into multi-class predictions, which is something more advanced to do that. So this is gradient boosting. And then let me show you the importance of our features. So can you see this one? So this is the F1 is the first one, F0 second. F1 is F0 and F1 is this one. This is F0, this is F1. So F0 has the importance score of 164 and 148 and 112 over here. So you can see that the importance graph from here for our features when we use gradient boosting. Okay, So this is the examples on how do we measure the predictions for the by using root mean square for to do sales predictions. Because when we predict the value, we can't really measure the accuracy. So before we do that, we normally I will use the root mean square error to check on the predicted the wrongly predicted value when I want to do any predictions. Okay. If you have any questions, you can leave it down.